Let's take a look at rearranging equations. So not all the algebra questions that we do are going to end in a x equals 4 or y equals 7 or something like that. Sometimes we're just going to rearrange them, and what they end up with is another equation, but an equation that's useful for solving another part of the question. We'll take a look at an example here. So if you're doing some home improvements, things like that, and you're looking to put some baseboard around a room, and you happen to have lost your measuring tape, which was the situation I was in at one point in time. So you painted the room, and when you check the paint can, you know that it covered 120 square feet. So you know the area of the room, of the walls, and you also know that the walls are 8 feet high, which is the standard height of walls. So to find the length of baseboard that you would need to buy, what you can do is just rearrange the area formula for rectangles. So the area of a rectangle is length times width. So area equals length times width, and we know that the area is 120. The length we don't know, but we know the width is 8, so it's 8 times the length. And then, like our basic algebra equations, we could rearrange that and do 120 divided by 8 equals L, or 15 equals L. So we know now the length is 15, which is fine if it's just a single use, but what if we need to continually try and find the length of this rectangle? You know, what if we have a whole bunch of areas and a whole bunch of widths or heights in this case, but we don't know the length? So rather than trying to rearrange the formula every time, we can actually make a new formula that'll solve for L. So if we start at the same point and we do area equals length times width, and what I did was I took the width, which was being multiplied by the length, and I divided the A. Well, I do the same thing here. We're solving for L, so I can just move the W over and divide A by W. So area divided by width is equal to length. And that's what's here. Our area is 120 and our width is 8, and we're just dividing those to get the length. Same thing happens here. So we can rearrange that. There is no answer in the sense of there's a final number. It's a new equation. So when we're rearranging equations, sometimes we just end up with a new equation that, in this case, might be a little more useful to us than the regular one where we have to rearrange it every time. Let's look at a couple examples. I have a few equations here that I just made up. In the first case, we have 4x plus y equals z, and we're going to solve for x. So when you see a little semicolon like this and a letter beside it, what that means is that's not part of the equation. This here is the equation. This here is what we're going to look for, and that's just my convention of how I note that. So in this case, we want to get x by itself. So taking a look at this equation, we got to move the y first. The y is furthest away from the x, so we'll have 4x equals z, or z if you prefer, plus y here becomes minus y. The same rules of algebra apply. We do the opposite operations. So we have the z plus, or z minus the y in this case, and now here in the next step we have a 4 times x. We got to move the 4 over. The opposite of times 4 is divide by 4, and we divide everything on that side by 4. So we looked at the original equation, moved the y over because it was furthest away, and just as if it was a number, we subtract it from z, and then because we had 4 times x left over, we have to get rid of the 4, and we did that. Multiplication becomes division. We make sure we divide everything by the 4. This could be written like this as well. X equals z over 4 minus y over 4. Both those are perfectly acceptable. This is just a little neater, but this is sometimes useful when you're trying to solve equations, or simplify equations, I should say. So depending on which one works best for you. In the next case here, little more complex. We have a plus b squared divided by 2c equals d. And we're going to solve for b. So the 2 and the c, in this case, happen to both be on the bottom of the equation. They're furthest away from the b. They're like equally distant away, so equidistant away. So we're going to move both of those at the same time. The opposite of dividing by 2c is multiplying by 2c. So we're going to have 2cd, 2c times d. Next, for this would be the a. So this is an addition question, and it's a positive a, so we're going to move that over, and the opposite of adding an a is subtracting an a. So 2 times c times d minus a. Now, we're still left with b squared, and we don't want b squared. We actually want to know the value of b. So the opposite of a squaring is a square rooting. So we're going to square root to get the final b. So b equals the square root of 2cd minus a. And we take the square root, again, of everything. When something moves over, it has to affect everything. So here, everything on the bottom was multiplied by the d. Here, everything was square rooted by the b squared. Up here, everything was divided by the 4. So make sure you take that into account. And if it's something big like that, everything has to be affected by it.